Hey, Nithya. I think I got this fixed, and we'll be able to record this video for you. Hang on a second. Okay, sorry, it's taking a minute to get myself together here. Okay, so I wrote all this out for you. I'm just going to talk through it. It may have made perfect sense to you the way I wrote it up before, but just in case. Wait a minute. Okay, so we have our sports car heading to the left or to the right at a speed of V1. I just called it V1. And its mass is 920 kilograms. Let me just sort of highlight what we're doing. That's this. Then it gets into a collision with the SUV. Then the two are stuck together with a total mass of 3,220 kg. That's the 920 plus the 2,300, 3,220. And it's going to go at a velocity which we'll solve for. I'm just calling V2. It's the velocity that the whole combined wreck is moving just after the collision, and then it skids to a stop in 2.8 meters. So the skidding to a stop, we're going to be able to calculate the frictional force. When it's skidding to a stop, that's mu times the normal force. That's mu times mg. That's the 0.8 times the combined mass of the whole wreck, the two vehicles stuck together, times g. That, if we multiply that times the distance, we get the work of friction in stopping that wreck. That is this in joules. You can verify that I did the math correctly. That work that friction does in stopping that wreck is equal to the kinetic energy of the wreck just after the collision. That mass of 3,220 kilograms, the two vehicles stuck together, moving at the velocity v2, the kinetic energy of that, which is 1/2 mv2 squared, is equal to the work done by friction in stopping that wreck. And so with that, we can solve for V2, 6.626 meters per second. Now I'm going to go over to another page where we now have V2, 6.626 meters per second. And now we're just going to look at the momentum. We're going to look at the momentum before the collision is the mass 920 times the V1, which we haven't solved for yet, which we're about to solve for. That has to equal the momentum after the collision, which is the combined mass of 3,220 times the V2 that we just solved for, the speed of the wreck, the stuck together vehicles just after the collision. The momentum before equals the momentum after, and that solves for V1, the velocity of the sports car just before the collision, 23.2 meters per second. So I hope this all makes sense to you. I'm going to see if this video turned out and get this over to you. And hopefully this is all good. I will see you later.